Now, before we discuss operational amplifier, okay, we were discussing the gain. Okay. So generally, there is a general gain is sometimes gain number is very high. Okay, like 10 to the power 3, 4. So we use a different unit called decibel. Decimal is dB. This is a logarithmic unit. Generally, our gain is a number. Okay, voltage divided by voltage. So that number sometimes can be very high. So, to write the short number, okay, we use a logarithmic unit and say gain dB is defined as 20 log 10 a dB. So for example, if I have a circuit, say minus plus, say this is 5 kilo ohm, here applying V input, say this is your how much? Say 50 kilo ohm, say this is 50 kilo ohm, and this is grounded. And this is your, I'm measuring the voltage here. So what is the gain of the circuit? Closed loop gain. What is the closed loop gain? ACL will be minus RF upon R1, that is 50 kilo ohm divided by 5 kilo ohm. That is the number is 10. Now when I represent this gain, closed loop gain dB, then what I'll tell? I'll take 20 log 10 mod of a closed loop. Okay. So mod this become 10. So this become 20 log 10, 10, and log 10 is 1. So this number 10 is basically your 20 dB. So many times we want to represent gain in the form of logarithmic unit. Okay. Now let us solve one problem which came in your exam recently, either in GATE or CSIR net, that you have been given a operational amplifier and the operational amplifier gain is given open loop gain. Open loop gain is given 40 dB. 40 dB. And the beta feedback factor is given as a 40, also given as a 1 by 40. Is also given 1 by 40. Okay. Now this is calculate the closed loop gain in dB. Okay. Find the closed loop gain in dB. Now, how to do this problem? What is the formula for you can only beta? So you have to use this formula. Closed loop gain is AOL upon 1 plus AOL beta. Okay. But this formula is for numbers, not for dB. Now AOL is given in dB. Okay. So first you have to convert this dB into the number. So now AOL is given in dB. It is given 40. Okay, 40 dB, which is equal to 20 log 10 AOL dB equal to 40 dB. Now this will give you a number. What is the actual number of this closed loop gain? Open loop gain number. So your AOL will be how much? 40 log of 10 AOL. Log of 10 AOL will be 40 divided by 20, that is 2. And your AOL will be what? AOL will be 10 power 2, that is 100. Okay. Now this number you can use in this formula and you can find a closed loop gain into the number. And again you have to convert this closed loop gain to dB. Okay. So now closed loop gain will be what? Closed loop gain will be your AOL. AOL is 100. This is 1 plus 100 divided by 1 by 40. Okay. So this will become how much? Tell me. 100. This will be your 5. This will be 2. So this will become 200 by 7. 200 by 7. Tell me what is 200 by 7?
Twenty-eight point five seven.
8.57. This is your closed loop gain in numbers. And now again you want to convert this number into dB. So closed loop gain in dB will be 20 log 10, 28.57. Okay. Now take the log of this one and tell me the answer. This should be something about 29 point something. I don't remember, but it's 29 point something. Tell me what is coming. Tilted.
29.1.
9.1. This is your answer. Okay. Fine. Okay, so let us discuss some more things about op-amp. So we've seen summing difference. Okay, now we'll see a voltage follower circuit. Voltage follower circuit. Now what is voltage follower circuit? That you have a op-amp, you're applying some V input here, and you're measuring V output here. So you are, tell me what is the output value if it is ideal op-amp? What is the output value? V naught is equal to क्या आना चाहिए?
One plus RF upon R1 multiplied by V input.
So where is the one? R1, nothing is there.
V input.
V input, yes, it should come V input. Because we know ideal op-amp. Ideal means both the voltage are same. That means this voltage is also V input. So V input will, so this is connected directly this one. So this is also equal to V naught. So V naught equal to V input. Now for understanding, you can understand, because this is your what? This is your 1 plus RF upon R1 into V input. Now RF is 0, short circuit, RF is 0. So again, V output equals to V input, and R1 is not there, it is open. So you can say R1 is infinite. Again, respect to 0, so V naught equals to V input. Anyway, you want to understand, you can understand. So whenever circuit is there, this is called voltage follower. Okay, this, so output will always follow input. Okay, so output follows input. Output follows input. That's why it is called voltage follower circuit. I don't know. I'm finding this is not coming. This is a little bit dull. This screen. Is it fine for you? This screen, Karishma?
Yes, sir. Visible, sir.
Yes, sir.
Okay. Now, next is your, there's one more important difference amplifier. Okay. Sometime that is actually experimentally very useful, used in circuits. That is called instrumentation amplifier. Instrumentation amplifier. And one problem also came in your chest. There are variety of instrumentation amplifier. We'll discuss one. So, what is instrumentation amplifier circuit? So you have basically 3 op amps. So 3 op amps. Output of this one is coming directly here. Here you have a R1, R2. This is your minus plus. Similarly, output of this one also coming here. R1, R2, and this is coming here. And in between these, here we have this plus, minus, minus, plus. So I'm applying some voltage, say V1 here, some voltage, say V2 here. Okay. And now you have a one circuit, one resistance here. Say I'm saying this is R1, R2, so this is R3. Here one more resistance is R4, and here one more resistance is say R3. It's the same. They may be different also, but for simplification, I'm putting same thing. If you want, you can take all R also. Only if this is changed. R4. So this is my instrumentation amplifier, and I want to find what is my V naught here, the circuit. So simple circuit is there. If you understand the voltage follower property, you can immediately solve this problem within a few minutes. Now say this is your V naught 1 and this is your V naught 2. This is V naught 1, V naught 2. Now, if I want to write this V naught, okay, this V naught, this is the inverting and non-inverting. Both are, we know the difference amplifier, how to write V naught. What is the formula for V naught? Tell me. Can anyone tell me what is the formula for V naught? This V naught.
R minus R2 upon R1 V is O1.
Very good. Minus R2 by R1 V naught 1 directly it will come. Then superposition principle. Then superposition principle. This is 0 because of this one. How much will come here? Now this is always remember इन्वर्टिंग में इनपुट यहाँ पे होगा और नॉन इन्वर्टिंग में आउटपुट डायरेक्ट होगा, तो ये डायरेक्ट इनपुट चाहिए। कितना है ये वाला V प्लस कितना है? दिस इज 1 प्लस सेम R2 by R1 into V plus. So V naught will be now minus R2 by R1 V naught 1 plus 1 plus R2 by R1, and this V plus is how much? V R2 upon R1 plus R2 into V naught 2. अब इसको सॉल्व कर लो, कितना आ रहा है? So minus R2 by R1 V naught 1. This is R1 plus R2. R1 plus R2 by R1. This is R2 by R1 plus R2 into V naught 2 cancels out. Okay. So R2 by R1. Then V naught 2 minus V naught 1. This is the formula for V naught, but I want in terms of V1, V2. That we have to calculate now. That means I have to now find what is V naught 1 minus V naught 2. This value I have to find out.
सर बाहर माइनस नहीं आएगा?
बाहर माइनस नहीं आए, कहाँ पे?
सर VO is equals to R2 upon R1 VO2 minus.
Okay, मैंने 2 ले लिया,
Yes.
2 माइनस ले लिया। Now you have to use the voltage follower properties. Okay. If this voltage is V1, that means this voltage is also V1. If this voltage is V2, that means this voltage is also V2. And now current is 0 here. Current is 0. No current is going here. So if this voltage difference is this one, current is only going here to directly here. And similarly, this point is V1 minus V2, current is going directly here. The current is same in this line because whatever current is coming R3, that is going to R4, same current is going to R3 because there is no current division. यहाँ पे कोई current नहीं जा रहा है. So that property we can use. So I can say my V naught 1 minus V naught 2, V naught 1 minus V naught 2 divide by 2R3 plus R4. That is my current I flowing in this branch is equal to same thing V1 minus V2. V1 minus V2 divided by R4. Same current. And now here I can replace this value here. Put it the values and solve. And there's some number will be given, say like यहाँ पे 1 volt, 3 volt, 5 kilo, some values will be given. So to put the values. So you can easily in numbers then directly you can put the numbers and you can solve. Now So yeah, V naught will be what? V naught will be now R2 by R1. This value is 2R3 plus R2 by R1. This will become what? 1 plus 2R3 by R4. And this will be your V1 minus V2. Okay, this V1 minus V2.
Sir,
Hmm.
sir, minus sign will come there, sir, because V02 minus V01 we are considering.
अच्छा तो माइनस आ जाएगा तो ये इसको V2 माइनस V2 कर दो. Now if you say everything R1, R2, R3, if R1, R2, R3 all are same, then you can put the values and tell what is the it's coming. If I put R1, R2, R3, R4, everything same, then what will come? Tell me. This is 1, 3 V2 minus V2. So this is the formula. 1 plus 2 R3 by R4, R2 upon R1, V01 minus V2 minus the V. Now let us do some more problems. What's time now? Now let us discuss differentiator circuit. So we are only doing now only negative feedback. So this is your minus plus, this is your R1, your Rf. So if I put a capacitor here, instead of resistor, I put a capacitor here. I'm applying V input here. Is C. And now I want to find what is V naught here. We can find out what is V naught here. So this is op-amp is ideal. So this is 0. So obviously this will be also 0. Okay. So what I can write here, this is the difference of voltage. So if some current will be flowing, say IC, say in this direction, it will be this direction. And when current flowing, if it is coming here, this will be going here. You say this is IF. IF. So I can write IS equal to IF Okay. Now, what will happen? What is the capacitor current? Can anyone tell me what is the current across the capacitor? What is the current across the capacitor? If there is a capacitor is there, C
dvdt.
dvdt, very good. If I am applying something here, that is dv by dt. Okay, C dv by dt. Now here the voltage difference is what? Here voltage difference is V naught minus 0. Difference of voltage equal to IF. And IF is equal to 0 minus V naught upon RF. So this is, so assuming this is a charging current, okay. So I am putting positive, final minus low, because I am assuming this is charging. If discharging, then it will be 0 minus something, because I am assuming its current is going like this. So it is charging the capacitor. So this is the final voltage, okay. And this voltage is increasing, or voltage difference this is. So I am putting Vn minus V0. Assuming this is a positive plate, I am writing like this. So this will be now dV input by dt will be what, your minus RF by C this voltage difference is, if this voltage difference is V, then we write C dV by dt, and voltage difference is V input minus 0 V input, okay. And now this is dV by dt, this is V naught, okay. Now what I want V naught. So let me write now the expression for V naught output. So output will be now V naught will be minus RFC dV input by dt. This is my output. So output is basically what? Output is basically differentiation of input. Okay. Any signal you will apply is a sine wave, then output will become cos wave. Okay. Something you apply triangular wave, then it will become square wave, because that will differentiate at least one time. So let us understand with this a problem. This is the formula. Okay. Now I am giving you a input signal. Input signal is a triangular wave. Triangular wave is given as a V input, equal amplitude. This amplitude is equal, and this is time period is given here in milliseconds. This is 2 milliseconds, 0 to, then you have 4, this is 6, and this is 8. This is the time scale, and T is in milliseconds. Okay, and maximum output, this is your 4 volts. Now you have to find the output signal. You have to find the output signal. So let us find the output. So output is basically what? Output is basically V naught minus RFC dV input by dt. Okay. Now you write the first V input. You want to differentiate it. So to write in the equation form, V input will be what? Tell me. For 0 to T 2 seconds, this is the slope. positive slope. What is slope? What is slope of this equation? Y equal to mx. Slope is what? Tell me. Y2 minus y1. 4.
2.
4. 4 minus 0. Y2 minus y1. X2 minus x1. 2 minus 0. Time period is a millisecond. So this becomes 4000 divided by 2. That is 2000. 2000 is slope. 2000 volt per second is slope. So this is your 2000 T is the equation. Y equal to mx c. So slope is c is 0. And now for the time period of say 2 to 4. Okay, slope is same, minus 2000 t plus constant is what? Tell me. What is the constant? Put the constant value. So at 2 millisecond, okay, 2 millisecond, it should be, what is the value should be? 4 volt. And at 4 millisecond, it should be 0. So can I put 8 here? Tell me, this is correct or not? बताओ भी सही है कि नहीं है? 8 की 8000 millisecond, na? So 8, only 8. So for example, if you put here t equals to 2 millisecond, then my V input will become what? Is 2 minus 4 plus 8 4. So this is 4. If you put t equals to here 4 millisecond, then V input will be what? 8000. This is 8 plus 8, 0. It should be 0. So this equation should be correct. Now you have the equation, okay, and now you want to write output. For that output, you want RF and C value. RF value is given 5 kilo ohm, and this is given you for 0.2 microfarad. Okay. So now what is RFC? RFC is basically 0.2 into 10 raised to power minus 6 farad, farad, and 5 kilo ohm. So this become how much? 5 into 0.1, 1, okay, come 1, and this is what? 10 raised to power minus 3. Minus 3, okay. Tell me, is this the value? Okay, now let me calculate the V naught. So V naught is minus RFC dV input by dt. So for both the intervals, V naught will be what? For the first interval, this is 2000. Okay. So minus RFC, that is this one, 10 raised to power minus 3 into 2000. 2 into 10 raised to power 3. This cancels. So this voltage will come 2 volt. 2 volt for the time period 0 to t 2. Okay. For second interval, this is your what? Minus 2000. Minus 2000. Okay. So again, same thing. It will come minus 2 volt. So 2 to t4, it's a minus 2 volt. Now you can easily draw. So this is a fixed value. So triangular wave means y equal to mx. So x will be differentiated only slope, only constant value should come. So triangular wave will always give you a square wave. So you can directly now write. Say this is your input. This is your input. This is a 4. This is time period is 2, 4, 6, 8. Or this is a repetition only. So you can write the output now. Output will be what? Tell me. RFC. This is what? Seconds. dV by dt seconds. Okay, so it will become so this is seconds and this volt second the volt will come. ठीक है, so अभी क्या हो जाएगा, ये इस स्लोप के लिए 2 वोल्ट आना चाहिए, माइनस और प्लस, and here minus is there, here minus also there, that will be used here, so this will become minus and this will become minus plus, that will be used. Okay, minus plus. So for this interval this will come plus 2 volt, and for this interval it will come plus 2 volt, again minus 2 volt, again plus 2 volt. So this is your basically a square wave of 2 volt to minus 2 volt. Always remember the sign here, otherwise ऑप्शन वो वाला से करके जाओगे एग्जाम में तो गलत हो जाएगा, ऐसे कंफ्यूजिंग वाला ऑप्शन देता है आपको एग्जाम में थोड़ा सा माइनस प्लस में चक्कर में. And this is your 4 volt. अब किसी को कोई डाउट है तो बताओ. So there are many other also practical different circuit also that we will do later. Okay, this is just a elementary differentiator circuit. Leo, is that clear?
Yes, sir. Clear, sir.
और कोई है तो बताना, उसको नहीं है तो ऐश्वर्या, योशिता. I am rubbing this one. Okay, if you have doubt you can ask me.
Yes, sir.
So always this is differentiation, so you have to always write in the form of equation. We already discussed where we were doing the capacitor. Okay, so that's why all the basics I discuss everything in the network analysis. So later you should not have any just like a shock, something new is coming. The basic should be clear. Now the next is integrator circuit. Okay, integration. So integrator circuit. So integrator circuits, the circuit with op-amp is same like differentiator, only just we have to replace now the position of capacitor. Capacitor will come now here. You see, and this is your V naught. Put it be input here. This has become your integrator circuit. Now, whatever you input apply, output will be integration of that input function. Let us write the equation. Say this is ground, so this is 0. This V naught. Okay. So now current say going here. Say current is going here. Assume okay IC. This is your I1 say. So I1 is equal to IC. Again, I1 is your V input minus 0 upon R. And IC will be what? Tell me. Now the voltage is here 0 minus V. Okay. So I will write C d by dt. Always see what is the voltage. Current is moving like this is plus, this is minus, but this is the 0. And this is V naught. So you always write 0 in the direction of current. 0 minus V naught. So this becomes your V input upon R. This is minus C dV naught upon dt. And your V naught will become now this one. Different integrate this one. So integration, if you do integration, this will give you what? Minus 1 upon RC. and then this is integration v input dt. This will give the output. So whatever input, that integral will be your, the integration of that will be your output. So if you put a square wave, you get a triangular wave. If you put a sine wave, you would cos, sine with sine. Problems we see later. Now I will discuss some important, very important uh, application of op-amp, that is called filters, op-amp based filters. Okay, the filters basically what? Filter is used to filter out frequencies. Okay, whether so if you want you have a all kind of frequencies are coming out of the frequency, you want to remove some frequencies, reject some frequencies, okay, and keep others. Like you want to make high pass filter, you want a low pass filter, you want a band pass filter, or you want a band reject filter. Okay, so those filter, whenever we use op-amp filters, that is called active filter. And if you use the filtering with only using resistance, capacitor, and inductor, that is called passive filtering. Because when you are using op-amp is not only uh, filtering the signals, but also giving some gain also. That is why it is an active filter. While if you have only RCL, that is only do filtration job. So we'll do both kind of filter, active filter, and this is passive filter. So what is the filter? Put a heading the filters. So first is filters. What is filters? So filters are basically DC circuits designed to pass some frequencies while reject others. Okay, you want to find allow some frequency, you want to reject some frequency. Okay, filters are also again it will classify as a two filters. One is passive filter and one is your active filter. Okay, passive filters only use R, C, L. Okay, active filter use op-amp. Of course, you have to use RCL also. So basically, there are four type of filters I'm going to discuss. Okay, number one, low pass filter. Low pass filter means I write LPF, low pass filter. Suppose you are giving some signal, okay, with all frequencies. The signal is coming Vs with all frequencies. You want to only pass say low frequencies. That means you want to pass only this is cutoff frequency. Above this cutoff frequency, everything should be zero. So this is a low pass filter. It will only pass depending on what is the cutoff frequency of the signal. Okay, it will stop. It will pass this one and stop this one. So this is an example of low pass filter. Similarly, you have a high pass filter. High pass filter will you have frequencies, say Vs with all kind of frequency depending on the cutoff frequency of this signal and this filter. It will pass high pass filter. That means all frequencies below Vc will be blocked. Okay, so these will be blocked. So this is your high pass filter. So this filter is very important for exam. And the third one is band pass filter. Third is your band pass filter. Band pass filter. You have a signal of all frequencies, but it will pass only this range. Okay, of course there will be some frequency where gain will be 1. So this is the basically a range. It will pass only a range of frequencies. So your output will be basically a band will be passed between the range omega 1 and omega 2. It's all an ideal curves. Okay, you don't get actually this one, but it's ideal situations. And the last is your band reject filters. Last is your band reject filters. So you have a all range of frequencies, but between some range will be rejected. So frequency signal, you have band reject filter, and now band will it will pass low pass frequency, it will pass high pass frequency, but this band will be rejected. This is pass band. So let us discuss each filter one by one. Can I erase this one?
Yes.
I'm erasing. Karishma, anyone, please stop me if you're not done.
Yes, sir, I'm done.
Now, first is your low pass filter. So I am only discussing first passive filters. So low pass filter using R and RCL. Okay. So if I want to use a low pass filter, say I have a signal Vs, all frequency, and this is my resistor and this is my capacitor. C. And here I'm taking the output. Now I want to find the gain, okay, as a function of frequency. Okay, I want to get gain as a function of frequency. Now what is the gain? Gain of the circuit is what? Gain of circuit is A omega, which depend on frequency, that is V naught by Vs. So I want to plot this graph. Okay. So first of all, let me write now what is my V naught here. So V naught is simply, now we are using AC source because the frequency is there. Different frequencies, it's not DC source. Okay. For DC it will be open. Now my AC source. So for AC, the capacitor behaves like a reactance. It has a reactance. Okay. For impedance, we write by XC. So now the rule of the game is same. If you want V naught will be what? V naught will be simply XC. Here voltage I want plus voltage divider plus 1 by XC into Vs. And now the gain, which is a function of frequency V naught by Vs, will be XC plus R plus XC. And XC for capacitor is 1 upon iota or j omega c. This iota, which you use in complex, not the complex numbers. Now you can put the values. So gain as a function of frequency will become 1 by j omega c. Okay. R plus 1 upon j omega c. If you solve this one, j omega c cancel. This will give me 1 plus j omega c r. This is my gain as a function of frequency. Now let me write it some other way. Now if I put, say, magnitude, if I write the magnitude of this gain, this is a complex number. Okay. If I write the magnitude of gain, this will be given by 1 plus j omega square c square r square. Is it okay for you? Can I write like this?
Yes, sir.
Okay. And what is the phase of this number? Phase will be, tell me what is the phase? Because you want complex number, magnitude with fame, because you are writing the phasor form. Na? So this is what? Phase. This is a number one. This part has a zero phase. The phase is, this is the numerator denominator. The phase will be what? Phi 1 minus phi 2. Here is the phase 0. So 0 minus this phase is the tan inverse. Tan inverse. What tan inverse? Y by x. If your number z plus iota y, tan phase is what?
Y over X.
Y over x. Here the omega c r. X is 1. This is here. And this will go up. So this will become minus 0 minus this phase, phi 1 minus phi 2. Okay. I like phi 1 minus phi 2, 0 minus this phase is tan inverse omega CR. So basically my phase become minus tan inverse omega CR. Okay. Now let us discuss this gain as a function of frequency. If I say my omega is infinite, then my gain become 0. For high frequency gain become 0. And if I say my omega is 0, then my gain tends to or equal to whatever you want to write. Okay, 1 times 0 is 1. So for low frequency, you are getting the gain. High frequency, you are getting the gain. Basically, it is behaving like your low pass filter. And now if I say my omega is omega C, which is 1 by CR. Okay. If I say measure the gain at cutoff frequency here, cutoff frequency, omega is 1 by CR, then the gain will be 1 by root 2. Okay. Then the gain will be 1 by root 2. If I put omega C, omega to omega C, omega is 1 by C by CR. This will be 1. So 1 plus 1 by root 2. 1 by root 2 is what? 0.707. If I define a frequency like this, so with this definition of frequency, what I can write my gain as 1 plus j omega by omega C. This is infinite, this is 0, this is 0, this is 1, low pass. Okay, this is a low pass. And of course, you know the phi and magnitude, you know this magnitude, and phi also know for this number. Now, what is cutoff frequency? I have defined here. So omega equal to omega C is a cutoff frequency. Okay. So cutoff frequency is the frequency at which gain remains or becomes 1 by root 2 of 1 by root 2 of what? Zero frequency gain. Here low pass is for low pass, it will be zero frequency gain. Or for low for zero frequency at, so cutoff frequency is the frequency at which the gain remains 1 by 2 of omega equal to 0 gain. Omega 0 frequency gain. Now let us plot the graph. Okay. First note down this one and then we plot the graph. So if I plot the graph of my gain as a function of frequency, this gain is 1 at 0 frequency. Now you can put frequency omega or f also. Okay. If you want to write this in the frequency of linear frequency, then you can write 1 plus j f by fc. Okay, omega is 2 pi f. So if I plot this as a function of frequency, this or this linear frequency, then this is 1 here, and then this goes down, and then this infinite frequency, this becomes 0. Okay. It just drops like this. And this is the cutoff frequency. The cutoff frequency at which gain is 0.707. 1 by root 2. This is my cutoff frequency FC. Okay. So this is the curve. Now if same scale, same graph, if I put up, if I draw at a logarithmic scale, that means if I say my AW is in dB, if I convert this number in a dB, okay, and this is also log of frequency, then this drop will not be faster. It will be a little slow, and this curve will look like this one, because this is my ideal curve, na? It's an ideal curve for low pass filter. Below cutoff frequency it will pass, and here should not be pass. So if I draw this same data on log scale, log of gain, that is dB, and log of f, then this drop will not be faster. Up to this frequency, it will be almost, it's not really constant, it will be almost constant. So I can draw like this. So this is my low pass filter graph. Similarly, if I now do it for phase, how phase is changing with the frequency? If I plot the pi versus frequency graph, so if frequency is infinite, this become 10 infinite is 90 minus pi by 2. Okay, if it is 0, 10 0 is 0. And if 10 1, 10 1 is 45. So this frequency, this graph will go like this. Say, it will start from 0, na? Will start from 0. So the graph of phase, okay, this phase, it will go, it will approach to minus pi by 2. It will approach to minus pi by 2. So initially it will increase, it will go like this. This is minus pi by 2. Okay. At some cutoff frequency, FC, when omega is 1 by C is 1, this will be 45. Okay, pi by 4. And at 0, 0 it is 0. Phase is 0. So this is phase with frequency. Phase is also changing with frequency. So this is your low pass filter. Similarly, now we can have high pass filter. So same, only now for high pass filter, you just replace this R here, C will go there. So I'm erasing this one and now put the heading high pass filter. High pass filter is C will come here, R will come here, and remaining calculations are same. You are measuring V naught. Do it now. High pass filter. This is C. So gain as a function of frequency will be V naught by Vs, and V naught will be, now I'm taking the across the R. So it will be what? R upon R plus XC into Vs. So now my gain will, I'm rubbing this one. So gain will become A W V naught by Vs. This will become R plus XC. That is R plus 1 by J omega C. Okay. And then now you write what? You take common. So this become, or let it be like this here. You take R common. So this become what? 1 plus 1 by J R omega C. J omega C R. Okay. A, the function of frequency. And now if you want, you can define CR, 1 by CR as the cutoff frequency. So this formula will become, now you can have here, J is there here. Nah? So what you can do, you multiply J up and down. So this become 1 upon 1 minus J omega CR. And this also you can write as a 1 upon 1 minus J omega by omega C. So this is my expression for this one, 1 upon 1 minus J omega by omega C, expression for gain. And now you can write the phase as well as magnitude.
सर ये ओमेगा वो माइनस वो कैसे हुआ?
ये माइनस कैसे हुआ?
अब वो ओमेगा सी है तो नीचे था ना, ऊपर कैसे गया?
Omega C is defined as 1 by CR. तो ओमेगा को तो ओमेगा ऐसा कैसे रख दिया? ओमेगा सी ऊपर आ जाएगा ना, ओमेगा सी ऊपर आ जाएगा, ओमेगा सी ऊपर आ जाएगा. This 1 by CR will be omega C and this omega, correct? This will be omega C, omega. Now write the magnitude. So magnitude of the gain will be, and so magnitude of the gain will be 1 upon under root 1 plus omega upon omega C by omega का square. Low pass में ये ऊपर था, high pass में ये नीचे है. And now if you say omega is infinite, so this infinite is 0, gain is 1. High frequency gain ज़्यादा है, high frequency stable है. You go to the 0, A omega will become 0, and if you go omega equal to omega C, gain again will become what? 1 by root 2 of 1 by root 2 of 1 by root 2. That is 1 by root 2 of the gain at higher gain at infinite frequency. And you can write. हाँ बोलिए.
सर राइट साइड में जो सर 1 अपॉन 1 माइनस सर जे ओमेगा सी आर लिख रखा है सर.
हाँ
सर ये कैसे आया सर? 1 अपॉन है ना सर वो?
हाँ हाँ हाँ.
सर ऊपर जे से मल्टीप्लाई हो तो जे ऊपर आएगा ना सर?
जे ऊपर आ गया ना. अच्छा
हाँ सर.
मैंने गलती कर दी क्या? जस्ट मी.
हाँ सर ये
1 मिनट. आर जे आ गया तो मैंने जे से मल्टीप्लाई किया तो जे ऊपर आएगा. जे ऊपर है, जे ऊपर है ओमेगा सी. अब जे ऊपर ही है ओमेगा सी. अब ठीक है ना, ये हो गया ओमेगा सी ओमेगा. अब ठीक है, जे ऊपर ही है. जे मल्टीप्लाई किया, जे माइनस 1 अपॉन नहीं किया था मैंने. ठीक है, फिर कर दो इसको. तो लिखे उसमें भी याद करना चाहिए. What is the phase? The phase will be this number 0 minus, this is 10 inverse. Okay, so phase will be phi 1 minus phi 2, 0, this is minus 10 inverse omega c by omega y by x, minus plus हो जाएगा, because this is minus come here, this is minus, so this come phase, so phase will be your 10 inverse omega c upon omega, or 10 inverse fc upon f. Okay, or if you put the value of this omega c, then it will be 10 inverse 1 upon 10 inverse. What is the value? Tell me. 1 by omega cr. The phase. Now plot the gain versus frequency, and the gain, and then you can plot also the phase also. So if I plot now, same way जैसे पहले आया था वैसे आएगा. Gain versus omega f और omega. इनफाइनाइट पे कितना है आपका? 1 है, 0 पे आपका 0 है, तो this will go like this. At higher frequency, this will approach 1. Will approach 1. And some cutoff frequency here, FC, this will be 0.707. And if you draw in the dB or log of f, then what will happen? This curve will come only like this. This will become 0. Phase is positive, so you can easily draw a phase at 0. You want to plot this one phase. At 0 frequency, this is 10 infinite pi by 2, and that is going 0. Okay. And some frequency, say fc, this pi by 4, 0, this is pi by 2, and then infinite frequency coming 0. Okay, so let us stop here. Band pass and band reject we'll do tomorrow, and then we'll do filter with op-amp. Okay, I'll stop here. Thank you.
Thank you.